All right, let's start. Sharpie, can y'all see it? Hopefully, yes. Can I read it?
Yes.
All right, let's go. Come on. Let's see. I'm gonna do these two problems right here. This is from test number 2. All right, 19 we already did it, but I'm gonna do it again because people are like lost on it. This one right here. So number 19, it says 20e to the negative 0.1x is 2. So step number 1, divide by 20, divide by 20. These are gone. So e to the negative 0.1x is calculator. Doing the calculator. Do 2 by 20. 2 divided by 20. All right, give me a number. What'd y'all get?
0.1.
1? Okay. So now you do ln of this number, 0.1x. And you do ln of this number, so negative 0.1x. ln of e is ln of 0.1. Okay, so now let me write this formula here. ln of e is a 1, and ln of a to a power is n ln of a. Okay, so now, so negative 0.1x times 1 equals ln of 0.1. Negative 0.1x equals ln of 0.1. So now, divide both sides by 0.1, 0.1, and x is, tell me a number. What do you get when you divide that one by that one? Give me like 6 numbers. ln 0.1 divided by negative 0.1 is what?
23.02585.093.
23.0258. That's enough. Y'all get that? 23.02? All right, let me change. I'm going to do it one more time. Same problem. 19.999. I'm going to say 20 e to the negative 0.1x equals 5. Same problem. I just changed the number to a 5 on the side. Still going to divide it just like the other one. Divide this one by 20 and this one by 20. These are gone. E to the negative 0.1x equals 5 by 20. Give me a number. What'd you get?
0.25.
0.25. So ln of this number, 0.1x, and ln of this number, 0.25. 0.1x times ln of e equals ln of 0.25. So negative 0.1x times 1 equals ln of 0.25. So now 0.1x equals ln of 0.25. So divided by 0.1 divided by 0.1. So do it in the calculator. So what y'all get? ln 25 divided by negative. What'd you get?
13.86294361.
That's good. 13.8629. That's enough. 6
Yes.
numbers. Fine. Okay, that's right. All right, so let me change the number. I gotta do it one more time. Just to make sure that you know how to do this. Page 1. Page number 2. 19.7777. I'm gonna say, let's say 40,000 e to the 0.05x equals 320,000. That's good. Let's just do that one. All right, this one. So I'm gonna divide both sides by 40,000. This one by 40,000, and this one by 40,000. Okay. It's grandma's house or something. All right, she bought it for 40,000. Eventually, it was worth a lot of money, 320,000. So how long does it take to get there? So these are gone. So 0.05x equals, what's 40,000 into 320,000? Do it in the calculator. What is 320,000 divided by 40,000 become?
8.
8. Okay. So now you have ln of e to the 0.05x, ln of 8, 0.05x times ln of e equals ln of 8, 0.05x times 1 equals ln of 8. 05x equals ln of 8. So now divide by what? What number?
0.05.
Yep, 0.05, 0.05. These are gone. So x is, so how many years is it going to take for, we'll say this is poor grandma. So for her house to go from 40,000 to $320,000 house. So what number?
41.
Point
5888.
5888. Okay, that's good. So 41.5888. Let me do my machine real quick. 8 divided by. Yep. Right. So now let's go one more like this one. Let's go to the rich grandma house. All right. She bought a house also, and she paid more money. She paid 44,000 for her house. But in her house neighborhood, it's faster, not 5, it's 12%. They're going, and it's gonna go. Make it the same. Well, this is like this. 320,000. All right. So she bought her house for 40. She bought a house for 44,000. So now I'm gonna divide both sides by 44,000. This one by 44,000. And this one by 44,000. 1, 2, 3, 4 zeros. There you go. These are gone. All right. So they're 320,000 divided by that number. 3 divided by 44,000. All right, just give me like 6 numbers, I guess. What'd you get?
727272.
727272, like that? Like that? 7.2727, like that?
No, sorry, 0.727.
Say it again. So 7.272727. Is that what you said?
No, sorry.
Okay, tell me what it is.
0.727272.
It's not 0.72. Do it again.
No.
Do the big number on top and the little number on the bottom. Do the big number on top and the little number on the bottom. Big number on top. Do 32,000 divided by 44,000. Okay, what'd you get now?
7.2727.
Okay, that's good enough. All right. So now we're gonna do on both sides. Take ln on both sides like this. 7.2727. So 0.12x times ln of e equals ln of 7.2727. So 0.12x, and this is a 1 always. 7.2727. So 0.12x equals ln of 7.2727. So now I'm going to divide this side by 0.12. And I'm going to divide this side by 0.12. Okay. So do that on the calculator. Do ln 7.2727 divided by 0.12. Okay. What'd you get?
16.5343.
All right, that's good. So this guy took 41 years to get there. And this other grandma in her neighborhood, things are jumping up faster. So it went from 44,000 to 320,000, just like the other one. Except this one took 16 years for that to happen. 41 years, sell it for this price. 16 years, sell it for that price. Does that make sense for those numbers? Hopefully, yes.
Yes.
Yes. Okay. All right. So now let me do this other problem. Number 3, page 3. All right. So now I'm going to do the other formula. We did this one already. Those are okay. So now I'm going to do this one. A equals P times 1/2 to the, let me just write it out. So A equals P times 1/2 to the power of T over N. Like that. Is that it? Yep, that's it. All right, so we did this one already. So I'm going to do this new one over here. All right. So now I'll show you how this one works. This one is called half-life formula. Okay. And it's from different things. Like it's from chemistry. If you ever had that, maybe. It's from physics. You ever had that, maybe. Okay. And it's from there. But anyway, I'll show you how to use it. So, and it's for carbon 14 from our periodic tables. You ever heard of those things? Periodic tables. Right. Anyway, I'll just show you how that works. Let's say you go to great grandma's house. Okay, not your grandma, but her mom, great grandma's house. All right, you go there to visit her. All right, she has a nice giant house with all kinds of antiques and stuff. Everything's all like a bunch of money, rich. All right, so when you go to great grandma's house, you're gonna tell you know what? The grandkids, y'all need to go outside in the backyard. Where? You need to go outside in the backyard. Because I don't want you to be playing inside my house. I don't want you to touch my furniture. I don't want you to touch my sofas. I don't want you to put your feet on my white carpets. I don't want you dirty nothing antiques in here. So you go outside in the back and have fun. Okay? So you go to great grandma's house, you know, outside in the back. So you go to the back, and there you are with the other grandkids. So what you do is, since it's just a giant yard and that's all it is, this is what you do. You turn on the hose, the water hose, and let it run. And you're gonna get, if you turn on the water hose and let it run for a while, you're gonna get, so you're gonna have dirt and you have water, and you mix it all together, you're gonna get something called mud, M-U-D. Okay, you can get lots of mud in the backyard of their grandma's house. Then you start just digging up, putting more water in it, get more mud, and have fun. And that'll be fun in the backyard, grandma's house, great grandma's house. Now, if you start digging up more holes in the backyard, like that, bigger and bigger, dig out more dirt, more dirt, more dirt. As you're digging down there, all of a sudden, as you dig inside the hole like that, all of a sudden you go, hey, what is this? And let me just draw it if I can. Let me just draw it. And it's a bone. And it's about how many inches? This is about 16 inches. Let's say it's 16 inches long. From right here to right here, it's 16 inches. Like it looks like it's a leg bone of somebody. You find it buried under the dirt, underneath the dirt. You dig it up. You say, "Ooh, wow! Look what we found, Grandma." Tell Grandma, "Look what we found outside, buried in the dirt, outside in your yard in the back. What is it?" It's a big bone. Looks like a human bone. She looks at it. She goes, "What is it?" It's a 16-inch bone we found in the back, dirt, buried. So grandma's gonna tell you, you know what? That's like a chicken bone. So just throw it in the trash. Okay? It's a chicken bone. Don't worry about it. Just put it in the trash can. It's a big chicken, I guess. 16-inch, one chicken, one big bone. Put it in there and don't worry about it. Okay. You sure? I said, yeah, don't worry about it. Now, I'm going to tell you what's going to happen. The neighbor, lady next door, who hates your grandma because grandma plays music super late at night and she has 5 dogs. They always bark at night. Okay. She has dogs. She has music. As soon as she sees that through the fence, she looks, hey, look what those kids found, man. They found a big old bone in the backyard. And since this lady doesn't like your grandma at all, you think she might call these guys here? What do you think? She's gonna say, oh, they found a human bone? You know what? I'm gonna call the police right now. Tell them that the kids next door, they're digging up the stuff, and on the floor, they found the remains of some human bones, man. I'm gonna call the SAPD and tell them to come look at it. So call them, they'll come over. As soon as these guys get in there, they're cruisers, and they look at the stuff, they go, holy cow. This is like human bones, man. They're not gonna touch it. This SAPD just, you know what? We're not gonna touch any of this hair or bones, nothing. It's a bunch of evidence. It's evidence. There's a crime scene, man. We're not touching this stuff. So what they're gonna do is, I don't know. Let me ask you this other question. Have you ever seen CSI Miami or CSI Las Vegas or CSI New York? You ever seen those shows on TV? Yes or no? Tell me. CSI Miami, CSI Las Vegas, crime scene investigation, that's what they are, CSI. So Miami, Las Vegas, New York. But since they're San Antonio Police Department, they're gonna call these guys here. CSI San Antonio. These guys right here. Call CSI SA, tell them, hey, we found some human remains, some bone. We found bones so far. We found this one big bone. These guys are gonna come over and they're gonna start digging up more stuff at the yard. They're gonna start bringing the dogs in there, and they're gonna start looking at all the yard, that yard, the neighbor's yard, the grandma's behind the alley. They're gonna start digging all over the place to find if there's more stuff. Does that make sense? Now, when these guys get there, they're gonna start looking at. They can figure out when did this person die, and they can do that by the carbon-14 dating. They're gonna look at DNA stuff of this, the carbon-14 from the bone. They're gonna take samples of it. They're gonna take the whole thing, and then gonna start looking at it. Okay, so this is what's gonna happen. They're gonna take stuff from this, and they're gonna start investigating this for you. All right, so this is what's gonna happen. They'll get there, and they'll check it out, and they'll tell you, okay, what they found. All right, so let me put it this way, and I'll show you what they look like. Let me get an example of what it looks like. Hang on a second. All right, when the guys come over to your grandma's house, it's gonna look like this. Let me give you an example. It's gonna look just like this. It's gonna say CSI Crime Scene Investigators. It's not gonna say Las Vegas. It's gonna say San Antonio Unit. Okay, same as this. It's gonna say CSI San Antonio. That's the only difference. Okay, and they're gonna come. They're gonna take all the samples from there. Okay, you got it. There it is. They're looking at all your grandma's murero. All right. So now they're looking at it, taking samples of all the stuff. And they're going to take this back to the labs. Okay, they're going to look at it. And they're going They're going to use this formula right here to figure out when this person died. So now, let's say they check it, and I'm going to give you some numbers in a second. Let's say they check this thing, and they find out that this thing has 99.40 carbon 14 left in it. Okay, now let me tell you how this works. If you have a dog at your house, right now 100% of the carbon 14 is in it. If you have a cat in your house, then 100% of the carbon 14 is in the cat. If you have a fish in a fish bowl right now, 100% of the carbon 14 is in the fish. If you have a tree at your house, it's alive, then 100% of that carbon 14 is in there. You, if they take a sample of you, you have 100% carbon 14. All right. These are all going to be, if you're alive, it's 100%. And then when your dog dies, whatever, then it becomes from 100, it's going to go to 99, 98, 97, 96. It's going to keep dropping like this. 1 year, 2 years, 20 years, 15 years later, this number is going to get smaller and smaller and smaller. Does that make sense? I just got it from the CSI guys. So that's why I got this stuff from. All right. So now let's do this one. So right now, I'm going to put this number back in there. So I know right now that they found that 99.40 of the carbon 14 is still in that bone right there. That was buried. So now we're going to do the problem. Number 4. So this is 24.777. Okay, ready? So A equals P, and I'll tell you what all these numbers are going to be in a second. All right. So always, when it was alive, 100% was in it. Okay. And 1/2, and then T, I'll find out what that is. N is always 5,600. And this is just from a chemistry periodic tables. That's what it's from. Don't even worry about it. Just write it down. Now, we said that this bone right here, the one you find at your grandma's house, it only has 99.40% of the carbon 14. Okay, that's 99.40% of the carbon 14 still in that bone. So they're going to put it in the formula like this: 99.40 equals that right there. So now from this, you're going to start working it out. So I'll just tell you the first step. Divide both sides by 100. So the 99.40 divided by 100. And this one divided by 100. Like this. All right, these are gone. So now 99.40 divided by 100. You told me what it is on the calculator. Do it on the calculator. 99.40 divided by 100. Give me a number. What y'all get? $99.40 divided by 100. Give me numbers. What'd you get?
.994.
994. Okay. So now we have this. All right. So now I'm going to take the ln on both sides. It's going to flip this thing right here in the front. ln of A. All right. So I took the ln of this number, 0.9940. and ln of this number. Same thing over here. Okay, so now ln of 0.9940 equals t over 5600 times ln of half. So now let me tell you what the next step is going to be, so you can just follow me. Okay, I'm going to divide this by ln of half, and I'm going to divide this one by ln of half, like this. So I know these are gone. So ln of 0.9940 divided by ln of half is T5600. Okay, that's what I got so far. So now, to get the answer, I'm going to have to multiply, to get rid of just the letter T, I'm going to have to multiply both sides by this. 5600 ln of 0.9940 divided by ln of half. And same thing over here, 5600 times T over 5600. And I know these are gone. So 5600 times ln of 0.9940 divided by ln of half equals letter T. So now, you're going to do all this stuff in the calculator. Let me show you how to do it on the calculator, okay? I'll show you how to do it. All right, you're going to put 5600 right there. ln 0.9940, close it, divided by ln again, 1 divided by 2. 1 divided by 2, close it. And all right, I got 48. Well, you do it in yours. See what you get. Okay, let me write something down here. Let me check this. All right, so let me do it like this. All right, so do 5600 ln of 99.9940 divided by ln of half. Give me numbers. Give me like 6 numbers. All right, I'm ready. Go ahead. Somebody do it. Work it on the machine. What'd you get?
$48.6205.
6205. That's good enough. And decimal right here between the 8 and 6.
Yes.
All right. So let me tell you what that happens here. All right. So 48.62 years ago, that person died. That's when it died, and it's been 48.62 years since it died. That leg bone right there. Now, let me do this. I want you to subtract this. 2020, which is right now, I want you to subtract 48.6205. Okay. So all we know is that Grandpa number 1 went fishing Mustang Island, and he never came back, and that was like in 1971. And they said that he must have drowned. They didn't find him. He's dead. So then Grandma got the money. Grandma got his everything, his Social Security, his money, his retirements, everything belongs to Grandma. Properties, everything's Grandma's. But if you subtract 2020 minus 48.6205, what do you get? What year is this? When did this bone here of this person, when did they die? Give me a year.
1971.
1971?
Yes, sir.
Oh, man, coincidence. It has nothing to do with Grandpa, right? Grandma already got the money and spent it anyway. She didn't care. Hey, I spent the money. All right, so this is one bone they found. Okay, so now I'm gonna tell you right now, they're not gonna dig out one hole in your yard. They're gonna start digging all over the place in this thing. So let me tell you what's gonna happen. So they're gonna come by those CSI guys and start looking all over the place. 24.999. So A equals P times 1/2 T over N. All right. So we know we found this thing here. Let me write it down. This one here. This one was 99.40, and this one died in 1971. Okay. 99.40 means in 1971, that person died. Now, as they start digging more and more, they might find another leg bone or something in there. Let's say they find a short one. This is a short one. A short leg bone. All right, they say, oh, we found another one then. In the back, where? Right there, buried underneath the other bone. Okay, so we're gonna also check this out. And this one has, just make up a number, 99.70. 99.70 of the carbon 14 is in it. All right, so what they're gonna do is they're gonna take this bone back to the lab. CSI guys, they're gonna take it back and start checking it also. So let's put it back in here. So when he was alive, he had 100%. But now he only has 99.70 of it left over. And all these numbers are the same thing. Okay, just like the other one, same setup. All right, so now my next question is step number 1. I'm going to divide by 100. And I'm going to divide this by 100. Like this. So these are gone. So 99.70 divided by 100. You tell me the number. What is that number going to be? Number? 99.70 divided by 100 is what?
0.9970.
0.9970 equals 1/2 T 5600. So we're going to do ln of this number, 0.9970, and ln of this number, 1/2 T over 5600. So ln of 0.9970 equals T 5600 times ln of 1/2. Goes to the front right there. So now I'm going to do the same thing we did before. I'm going to divide both sides by that ln 1/2. And same thing over here. ln 1/2. So these are gone. We have ln of 0.9970 by ln 1/2. We have T over 5600 right there. So now I'm going to multiply both sides again like we did before. We're going to multiply by 5600 times this number, 0.9970 over ln of 1/2. And same thing over here, 5600 times T over 5600. I know these are gone. So 5600, and then you're gonna do this in the calculator in a second, okay? By ln of 1/2 equals letter T. So T is gonna give me some number. Let me do it on my machine. Hang on a second. So 9970. I'm gonna do T of this one here. I'm gonna say this. Let me write the story down here. Grandpa number 2, he went fishing in Padre Island, and he disappeared. He didn't come back. When did he go over there? I think it was like in 1990 something. 1995, he disappeared and never came back. Never could find him. I guess he drowned in the ocean or something. I don't know. But anyway, calculator 56000, ln of 0.990, ln of half. Do all the stuff in the calculator, and let me do it on my machine also. Times ln. All right. What'd y'all get? Give me numbers. Give me like 6 numbers. What'd you get? Do this number by this number. This times this, divide by that. But do it in the calculator.
24.2737.
All right. 24.2737. Is that okay?
Yes, sir.
All right. And this is years. Okay. Years ago, this next bone that was dead 24.27 years ago. So I want you to do the same thing. I want you to subtract those two numbers. 24.2737. Subtract those two numbers. See what you get. Subtract 2020 today, right now, this year. Take away 24.2737. What did you get? What year did you get?
1995.
Okay. Oh, another coincidence, huh? And grandpa number 2, after that grandpa was gone, she married another guy. And this guy went fishing at Padre Island, and he didn't come back in 1995. I guess he drowned or something. But after so much time goes by, if they can't find him, they assume he's dead. Then grandma gets all the insurance money. Grandma gets all the security, Social Security, all the retirement. She gets all his properties belong to grandma. Does that make sense? So great grandma owns all the stuff from here. All right. So this is grandpa number 1, grandpa number 2, G1, G2. Okay, I'm gonna do one more of these. All right, one more like this. Same formula. A equals P times 1/2 T over N. Okay, so now, let me write these numbers again so I remember what they are. The first one was 99.40, and that person died in 1971. And then the other one, this one is 99.70, and this one died in, when was this, 1995? All right. So now, as they're digging, you're going to find more stuff. Let me get a number. Hang on a second. This time, I got the numbers there. Yep. All right. So this time, as those CSI guys are digging up more stuff, digging all over the yard, this time they find, I don't know what they find. Oh, I know what they find. How about this? They find a leg and a foot bone connected, okay? And they're gonna take it in, check it out, see how much carbon 14 is in it. I'll just make up a number here. For this one, let's say it's, I don't know. Let's go. How about 99.95 of the carbons in it? All right. So this one has, this one died in 1971. This one died in 1995. So we're gonna find out when did this person die. Back to this. So we know it's 100% when you start it, but this one doesn't have that. It has 99.95. 99.95 of this stuff left in it. So everything else is the same. 1/2 T over 5600. So 99.95 divided by 100. This one divided by 100 also. 100 right there. These are gone. So do this with 99.95 divided by 100. You do it on the calculator. What'd you get? What you get for the number? 99.95 divided by 100 is how much? What'd you get?
0.9995.
9995 like this. 1/2 T 5600. Okay, so now I'm gonna do the same thing again, just like the other one. 0.9995, and I'm gonna do ln of this number here also. T over 5600. And the power is gonna go in front again. 0.9995 equals T over 5600 times ln of 1/2. So now I'm going to divide both sides again. 9995 divided by ln of 1/2 and T 5600 divided by ln of 1/2. Like this. I know these are gone. So I have this number. All right, so now I'm going to ask you the next step. So I'm going to multiply both sides of this thing by what number? Tell me. Multiply the left side and the right side by what number?
56.
Right. 5600 times the left. 9995 divided by ln of 1/2. And the other side also by 5600 times T over 5600. And I know these guys are gone. So 5600 times ln of 0.9995 ln of 1/2 is T. So now you're going to do this in the calculator, of course. And I'll tell you when. To the other bad news, I guess. Grandpa, number 3, he went to Galveston fishing also. And he disappeared. When did he disappear? And not too long ago, 2015. All right. So give me the number. When you put those numbers in the calculator, what did you get for that? Well, this number is right here divided by 11.5.
4.04055.
Like that? 04055?
Yes.
Okay. All right. So that's what years ago. This other person, the foot belonged to somebody who died 4.0455. So now I want you to subtract 2020, subtract 4.04055. Tell me what you get from that.
2015.
Another coincidence. It has nothing to do with grandma. Grandma say that's nothing to do with me, man. Nothing to do with me. Okay. So she's gonna say, you know what? All I know is I already got the insurance money from all three of these dudes. So let me do that. Number 7. I got one more page of this stuff there. Number 7, the last page. All right, so let me put this back again so I remember what happened. So we know that this one was 99.40, and that person died in 1971. We know the other one, this one here, was 99.70, and this person died in 1995. And now we know that the foot person, this foot person, who had 99.95 died in 2015. Okay. So that's what we know. We know that this one belongs to this one, that one belongs to 95, that one died in 2015. We also know that grandpa number 1, grandpa number 2, and grandpa number 3, they all died in the same years. That's all. But they're just coincidence. It has nothing to do with grandma, okay? Great grandma. So now, finally, as they dig down there, one more time, they're going to say, well, let's dig some more. You go, oh, man, we found a good one now. Kind of like Dia de los Muertos. They found, what did they find? A skull, a head of a person. They look, we found these, and we also found this right now as we're digging up in your yard. So grandma's gonna tell you, yeah, so what? It has nothing to do with me, man. I don't know what you're talking about. That's what we found. And this one has 67.00 of the carbon 14. Okay. So that's 67.00. The other one's at 99.99. This one has 67. So we're saying that you're telling grandma, hey, you know what? We think you're responsible for all this missing grandpa, the insurance money. Maybe you have something to do with it. Maybe. Okay, I'm gonna tell you what grandma's gonna do right away. Grandma is gonna get her cell phone and she's gonna call this number here. How many fingers do you see?
4.
4, right? 4? All right. She's gonna get in her phone and she's gonna call this number. Ready? She's gonna call 4444444. And she calls that number in her cell phone here in San Antonio, 210 area code. What's gonna happen? Who's she gonna talk to?
A lawyer.
Ah, there you go. Exactly. And the lawyer's gonna tell her, okay, what's the problem? How can I help you? She's gonna look. For some reason, the CSI people are saying that I'm guilty of this stuff here, and I didn't do any of it, none of it. So the lawyer's gonna tell you, okay, well, here's the deal. We'll do your defense and stuff, but it's gonna cost you money. You understand that, right? You have money to pay for the lawyers. She's gonna say, yeah, I got money. I got life insurance, properties here, life insurance, properties here, life insurance, properties here. Yeah, I got Social Security. Yeah, I got cash. Don't worry about it. Okay, we can work on your stuff. So don't worry about it. They found 4 things back there. Now they're saying that there's another thing back there. They're gonna go ahead and take it to a lab and check it out again. Well, let them check it. Let's see what they come out with. Okay. All right. So let me do this last one here. This is exactly question number 24. They found this fossil. That's what they are. They're called fossils. And it's 67%. So let me write the numbers here. All right. So we know that Originally, this skull had 100%. Now it only has 67.00 of the carbon 14 in it. So we have 1/2 T over 5600. Okay, just like the other ones. Same setup. So you tell me, what's the next step? Divide by what? Divide by what?
100.
100. 100. 100. These are gone. 6700 divided by 100. Give me a number.
0.7.
Point what?
67.
That's it? Okay. Well, I'll just write it like that then. So 67. All right. And now, ln of 0.67 and ln of this one here, 1/2 T over 5600. So ln of 0.67 is T 5600 times ln of half. So now I divide by ln of half. And I divide this one also by ln of half. Like this. So now, these are gone. So I have ln of 0.67 divided by ln of half. Equals T over 5600. All right. So now, what should I multiply on the next step? Both sides.
By 5600.
Exactly. 5600 on both sides of this thing. So let me do it right here. So 5600 times ln of 0.67 divided by ln of half equals 5600 times T over 5600. I know these are gone. So I have 5600 ln of 0.67 divided by ln of half equals T. All right. So now, so this skull, they found all this stuff, then they found that one also. Dug it up. See a side guy say, you know, we found all these bones and the skull also in there. We're gonna go ahead and carbon DNA, carbon 14, all this stuff, and we're gonna see what we come up with. Okay. He said, Grandma said, that's fine. Talk to my lawyer. Don't talk to me. Talk to this guy. Or talk to Jeff or his guys. Okay. Okay. We'll talk to them. So this one, Grandma says, hey, no, I have no idea what that is. I don't know what that is. And this one's I don't know either. So, but this one I don't know. Well, how old is this one here? Give me a number. 30 years, 20 years, 50 years, what? Or some other number. What y'all get?
32, 35.49.
32, 35?
Yes.
Point
49.
49. It's an old whistle, man. So this is like 3,200 years old. So that grandma wasn't here then. It has not this for sure. This one has nothing to do with grandma. This one's maybe. I don't know. But anyway. So here's a question for you. If grandma married this guy and this guy and this guy, is it, I don't know, maybe this is possible or not. All right. And grandma's already, I don't know how old she is. She's like, let's say she's 86 years old, great grandma. Okay. She's 86 years old. And you think she could find grandpa number 4, yes or no? Think about it. She has millions and millions and millions of dollars in her checking account. And she has personal trainer and she has nice plastic surgery stuff. Can she find another grandpa number 4, but it doesn't have to be a guy like her. It has to be like an 80-year-old guy, does it? A 90-year-old guy, 85 something. Can she get somebody younger? You think? From 86, get something. Grandpa number 4 could be a lot younger, right? Like I don't know how young. What do you think? 80 years old? 70? 60? How about this? How about 50? You think grandma can get a 50-year-old grandpa number 4? You think? Is that possible? Or you think she's gonna say, you know what? I don't want to get married anymore. I'm done. I just want to go have fun. Forget about this. Because they always die. For some reason, they always go fishing and go away, right? All right. Let me stop there. So here's your 4 for next Monday. I want you to do this problem here. Ready? Go to test number 2 and do problem number 19. And we did this one already, but do it anyway. And number 24. 19 and 24. Okay, on your My Math Lab. My Math Lab. Okay, My Math Lab. Go to where? Number 19 and number what?
20.
24. Okay. And then number 24 looks like this one. You have to use that CSI stuff to figure it out. How old is this hand or how old is this bone, whatever they are. Okay. You know how to do it. You're good. You're good at it. All right. Any questions on those 2 questions, number 19 and number 24?
No.
No, you can do them. You have skills. Okay. Okay. Then I will see you on Monday. Okay. Have fun on the weekend. I shut off in 1 minute. Okay. 1 minute.
You want us to go ahead and start on test number 3 already as well?
No. Just number 2. Just do test number 2. No, let me, because I have some other ones I haven't finished in test 2. So let me finish all of them. Okay.
Okay, not a problem.
So on Monday and Wednesday, I'll finish up the other ones I haven't done. But no, not right now. No, just do test number 2 only. Okay.
Okay.
2. Just 2.
All
right, man. I'll see you later, guys. I'll shut it off in about a minute, okay? And this is from 11 o'clock to 12:15. This is Wednesday. All right, you got your assignment right there. All right, see you guys later, man. See you on Monday. See you Monday.